Welcome back to Algebra 2, Chapter 9, Section 5 in this book. And we have been doing some fancy math. So now we're going to add and subtract complex fractions. You're like, I thought the ones we did were complex. Well, these are going to be a little bit more complex. Okay, now now we all love fractions, right? Yeah? And remember that when they're easy, it's multiplying and dividing. It's hard when it's adding and subtracting. Why? Because they have to have like denominators. That's me kind of halfway abbreviating that. So notice with these, there are no equal signs. We still have not done the ones with equal signs. The equal signs are fun, but we are not there yet. So these don't have equal signs. And we're going to add an equal signs, but there's not one in the problem. We don't have two sides of the equal where we're solving for x. We're more simplifying or combining things. And before we can add them up, they have to have the same denominator. They do. So then, remember how you do it. You just write the denominator down, and then you do whatever the math says on top. 4 plus 5 is 9. Now, are we done? No, because we can cross out. 9 is made out of 3 times 3, so those can cross out. So we're left with no room to write it anywhere, we'll write it up here. We have a 3 in the numerator and an x in the denominator, so the answer is 3 over x. There we go. We fit it in. I didn't give myself enough room. Alright, these have the same denominator, so we just do the math. We write down the denominator, x plus 3, and then it's 2x minus 4. 2x minus 4. That is probably the easiest problem you will see in Algebra 2. Alright, so how about this one? This is not the easiest problem. Okay, so these sadly do not have the same denominator. So what we have to do is think about what are the components that make this up. Like this is a 6, which is made out of 2 times 3. These are x's, which are multiplied. This, you can tell, you can pull something out of this, right? So we have to try to make these the same. So this 6x squared is made out of a 2x times a 3x. I pulled a 4x out of this, so I was left with x minus 3, and 4x is made out of 2 times 2x. And do you see how these are the same? So I don't need that in my new denominator. They already have it in common. This side doesn't have a 3x, so it needs to have a 3x multiplied by the numerator and denominator. This side is missing a 2 and an x minus 3, so it needs 2 and x minus 3 multiplied by the numerator and denominator. Why are we allowed to do this? Because we're allowed to do anything we want in math, as long as we do it to the numerator and denominator. So now I've got a denominator that's made out of 2x times 3x and 2 and x minus 3, and it's the same. Now I'm going to straighten this out. 5 times 2 is 10, 10 times x is 10x, 10 times negative 3 is negative 30, and 3 times x is 3x squared. And I combined everything back to again. 2x times 3x is 6x times 2 is 12x squared. 2x times 3x is the same. Alright? So that's my like denominator, and now I just add my terms, and I put x squareds before x's, before bare numbers, and that's the answer. Fancy, difficult, but that's the answer. Sometimes you can factor this top and mark out that x minus 3, but sadly we couldn't do it, and we had to stop there. Okay, now what about this one? It's dividing, and to divide a fraction is to flip it, and multiply. So, but before we do any flipping, I need to go ahead and add these. They don't have the same denominator, so I have to make them have the same denominator. This side needs an x. This side needs an x plus 2. So I did that, and then I have my new bottom, x times x plus 2. 1 times that 2 is x, 2 times x is 2x, and 2 times 2 is 4. X plus 2x is 3x, and then there's the 4, and there's the bottom here. Now I can bring down the numerator and put my divide sign, and now I can flip it and multiply. So I'm going to flip this part, And I'm going to look and see now that it's multiply, can I mark anything out? And yes, I can. That x plus 2 can mark out. Now 2 times x is 2x, and 3x plus 4 is still on the bottom there. Look at the examples in your book. Make sure you understand them. Do the problems that they walk you through on your calculator. Make sure you do those. And come back and we'll do the last section of chapter 9. Math is great.